So we will now welcome General Friedling on stage. He's arrived. We'll go to the next panel, and the next panel is space situational awareness and space security. So please, Valentin, Romain, and Michel, if you allow me to say Michel instead of General, we go to the small table there. Si quelqu'un peut. Okay, so I welcome on this mini panel. So General Friedling, former space commander for the Armée de l'air et de l'espace up to 2022. He has held various positions in command units before, and now he has been funding and is now CEO of LookUpSpace. I do not say a startup because it's well funded now, so it's a small enterprise yet to make space safer and more sustainable. There is Romain Lucken as well, graduated from École Polytechnique, co-founding Aldoria in 2017 and now CEO of Aldoria since 2022. Aldoria is dedicated to space situational awareness, so we are in the heart of the subject. And Valentin Baral, head of Space Surveyors Department in CNES, after having had a graduation, a master degree in the Université Paul Sabatier, having spent some years in the CS group in space situational awareness as well. And now in CNES, he has been in CNES for 3 years, 2 years, something like that. So head of space surveillance. So we'll address this, let's say, topic of space situational awareness and space security. From, let's say, it's a complex subject, I know. We are at the beginning. It's something that is always on the agenda of many governments, many agencies, to know what's going on in space, again, to protect our assets in space, which are essential for our life on Earth. So the question is maybe, as it is complex, and it is becoming even more complex with the number of satellites and debris that we see every day coming on stage, whether they are, let's say, active or debris passive. This is making things complex. And of course, you have to imagine for those who do not are addicts of space, that what's going on the other side of Earth you cannot control if you don't see it. So you really have to make use of automated aspects and, of course, predictions. So it's complex, and that's probably where AI can bring us some ideas. So in order to introduce the panel, I would like to have a little bit quick round table, on which of the topic you think AI could bring us something, either because it is something that you're already working on, or because it's a pain point that you feel in order to satisfy your users, your customers, that you may consider as essential to solve. And we will do it in the round table, meaning you say one, and then the other says the second, and the other say the third, allowing, of course, not to repeat everything the same thing. Can we, are you up to steam, Michel? Let's say, you start then.
Okay, thank you, Jean. Hello, everybody. So just in a very few words, we develop at Lookup a radar, ground-based radar, to detect and track objects in space, and we intend to deploy a global network of these radars around the globe. And we also have a digital solution consisting on in a digital platform plus algorithm. So we have this infrastructure part of the solution plus the digital solution. So AI, of course, we have been looking at AI since the beginning. Actually, we have a PhD full-time working on the subject at Lookup. So I think we have good insights. We are pragmatic. We do not say that AI it's bullshit, if I may. I'm sorry. We do not say either that this is the relevant solution for everything that is on the table regarding SSA and SDA. So, of course, the pain point in our domain is that supposedly we have a lot of data, a lot of objects, and obviously to treat this amount of data, we might think that AI is a solution for processing the large volumes of orbital data and sensor measurements, and to anticipate behaviors and to calculate all the risks of potential collisions in space. But I think we will elaborate on this. I think it's much more complicated than this.
So you give already two, large volumes and anticipation. Romain, next time.
Yeah, thank you, Jean. So yeah, in a nutshell, at Aldoria, we deploy, run, operate, and exploit a network of ground-based optical stations. We have 16 telescopes spread around the world at the moment on 5 different sites, so already a global network. We've detected more than 21,000 objects in the past quarter, and we're ramping up our data production. Of course, in order to collect this data, identify the objects, correlate them, you need a very powerful data processing chain. And some of the bricks, the building blocks of this chain, use AI for sure. And just to start, one of the key elements of AI since the beginning for us is the image processing, the computer vision part of the processing chain, which is very upstream in our data processing. Of course, we do that on the edge. So we have image processing algorithms directly on our stations, just 1 meter apart from the telescopes. And it's an area of continuous improvement for us. Of course, we're more users of data algorithms. We don't invent new algorithms. We just implement them, optimize them in order for it to work very effectively.
Okay, thank you. Valentin?
Thank you, Jean. So to complement what my colleagues just said, at CNES, one of our goals is to make sure to enforce the reglementation, so the law, the space operations law. And AI could be a very useful tool in that regard, since it could be very powerful to analyze patterns of life of objects and identify events, significant events that would be brought to the attention of operators that check that every operator is indeed operating in the bounds that have been set by reglementation, for example. This is just one use case, but it's more tainted by the institutional aspects of things. This is why I'm bringing it up.
No, it's a compliment. Something to add on top of what we have? Where we had today a large volume of data to be processed, anticipation of the behaviors, identification and correlation of the objects, let's say characteristics using computer vision, doing that in edge computing. And there is this law enforcement aspect, what I call gendarmerie, to make sure that you control what the people are doing in space because of the space law. Michel, you want you seize the microphone as is?
No, just maybe to add that it can help reduce the calculation time compared to other models. But again, it's not that simple, so I guess we're going to deep into this later.
Yeah, it may, yeah. If the algorithms are efficient and frugal. Yeah.
Can I add maybe one last thing?
Please.
One thing that's already being explored is the tasking of sensors. We're starting to have lots of sensors and by different sources. Some of those come from the industry. They're present here today. Some of those are institutional. They can come from civilian means or from military means. All those have different constraints in terms of how they can be tasked, in terms of how much time can be allocated to that kind of activity. And there is a balance to strike between surveillance and tracking, which are two different kind of activities that sensors can pursue. So this is a very complex optimization problem, and such problems are usually better solved by AI solutions.
Okay.
Yeah, very much concur on your 2 points, Valentin. Maybe to elaborate a little bit on the anomaly detection for law enforcement. That's one thing, but we see it as well very much from the other government customers that want to understand, what's going on in space. So basically, all kinds of applications using time series of orbital data are very relevant for pattern recognition and anomaly detection.
Okay, I think we are quite complete, and we cannot be 100%. It would take ages. Thank you for that. Say there is a use case which is there, which was resident in what you said, with the numerous data sets, heterogeneous sources of data, numerous sensors, even if they are homogeneous, but they are in different regions. They have got different characteristics. They may have as well different calibration and compensation of whatever, weather, atmospheric disturbances, whatever. Is AI already used in this specific domain to have these all heterogeneous data made on the same ground and aligned to each other in order to be accurate? Let's say maybe starting with you, Valentin.
Well, this is definitely a very concrete use case, which is data fusion, and this is something that is being explored right now, and it's going to keep getting explored for the next few years in terms of attitude estimation. This is something that is a sort of a new field. Right now, the orbital catalog that we try to produce, and that is a description of all the objects in space and their trajectories with robust predictions of those trajectories, is only interested in the center of mass of the objects. And in fact, it's oftentimes very interesting also to know the rotational state of the objects. And this rotational state can be inferred by many different kinds of sources of information. You can have actual pictures of the objects coming from space, or from on-ground optical sensors that have adaptive optics systems. You can have also light curves coming from telescope from the ground too, which are just the variation of the intensity of light coming from the object over time. And you can have radar cross-section curves too that can come from radars. And all those sources of information, they are very different. They are heterogeneous by nature. And each one can be used to gain some of information on the rotational state. But what we would like to do is have a system that takes all those sources in common and is able to aggregate the information into one solution, into one, the best kind of information that you can get on the rotational state of the object. So this is one example of data fusion.
Data fusion for a dedicated purpose, which is difficult.
Yes.
Romain, a complement on this fusion of data?
Yeah, well, the characterization element and like being able to identify the attitude motion of the satellite is definitely something very, very interesting and important. Maybe prior to that, we have already the orbital mechanics and the computation of the trajectory using heterogeneous sensor sources, and for that, we've done some studies internally to try to identify the biases of various sources of data, and try to correlate these biases with external factors in order to reduce the noise and to improve the accuracy of the information. So that works to some extent. We lack of ground truth data, so very much, picking up on some of the comments that were made on the previous panel. We lack of ground truth data. There's the GNSS satellites have a very high accuracy orbital data available. Some LEO satellites as well, but that is definitely a challenge. So if you want to overcome this challenge, you've got to use synthetic data, which you may do, but I'm not aware of many studies in this area, and nothing operational to my knowledge.
But what you described on the trajectography and the usage of heterogeneous data and reducing the noise, filtering that all together, is that AI or is that, let's say, classical?
Yeah, no, it's absolutely, it's AI. Basically, you have biases on time series of orbital data, and you want to correlate, and you assume that there's some correlation between these biases and some external factors, but you have no clue how to fit it. So it's really optimization using like neural network. So it's it's like typical AI tools that are used to infer these.
Michel, about the fusion of data, let's say you use radars, but not only?
No, actually we have a multi-sensor approach, even though the radars will be the backbone of the capability. So we are agnostic to the data. We have built from scratch the platform to be agnostic to the data, and we have built our algorithm to fuse the data. And I think at that stage it is important to make sure that we are discussing about the same thing, aggregating data or fusing data. Okay. Which is quite different. So we don't think at that stage that at LookUp, I mean, that AI is the answer for data fusion. We have already developed extremely advanced and powerful data fusion algorithm to determine orbits from different sensors, not only aggregate and reject measurement from different sensors, and to elaborate relevant global space situation. So for us, it's purely, at that stage, apart from use cases like the one you mentioned, it's purely a problem of algorithm and computing capacity. And also, so it depends purely on the power of the algorithm and the calculation. But also, and this is one of the very important points, on the quality of the data, on the volume of the data and the rate at which it is updated, which is a paramount factor, not only for AI, but also for the learning of the model that you are using.
Mm-hmm. Okay. Say, switching on ground truth data, next question would be why not orbit truth data? Say, we are talking about radars, optical sensors in every location, networks of stations, probably laser trackers as well from the ground. Do you think that you need orbit truth data, meaning that the initiatives to have satellites dedicated to do space situational awareness from orbit will be useful for your functions, first of all? And is there some edge computing possible there, meaning AI shared between ground and in orbit? Starting with Michel, for example.
I'm probably not the right person to talk about the edge computing on board satellites, but because we have mainly ground sensors, but we definitely aim at benefiting from data from space-based sensors, because like I said, we are agnostic to the data. But regarding edge computing, I'm much more qualified to talk about this because we are working on edge computing, and as a matter of fact, we have developed what we call a Synapse Edge. The name of the platform is Synapse. And Synapse Edge is the edge computing very close to the radar because we need to process data from before we send it back to the platform. And actually this is a component that it is already funded by the European Defence Fund in our solution. So it enables the radar data to be pre-processed before sending back again to the platform. But in this regard, I don't know if there is any potential for AI in Synapse Edge, and of course in space-based computing.
Okay. One of you?
Yeah. Well, you said two different things. You said we need ground truth data, so we need basically the accurate data from the spacecraft, which could be used at the ground truth, and then we need to leverage the spacecraft to monitor the space situation with onboard sensors. So these are two different things, right? Okay. So sharing accurate ephemeris from the satellite operators and between the satellite operators and between the satellite operators and the people involved in SSA is something super very important, and of course CNES is playing a key role in that direction. And it could definitely help improve the quality of the space situation monitoring as a whole. Regarding the second question, well, it's really a different topic. There are a lot of challenges in regards to putting a payload into space to detect objects. We see some very clear defense use cases for intelligence, for early warning, but for pure what we call SST, so space surveillance and tracking, detecting objects and retrieving the trajectories, the gains are limited in regards to the cost that you have to bear.
Yeah, in that direction, but maybe the question will be in the direction of helping you, thanks to sensors in orbit, to do your job of SST, SSA. Maybe not, but in order to help the one who are in orbit to see where to detect what, for example, and maybe using some predictions based on AI, why not? Is that something credible?
Yes, this is something we actually advocate a lot at CNES and in Europe, mainly EUSST, which is a partnership of European countries who congregate to do SST. This is something primordial that we need to understand, is that operators do not pursue accuracy in terms of how they locate their own assets usually. Because this is driven by their mission, and that's it. They basically produce the orbit that they need for station keeping and for assuring the mission, and that's it. And SSA is not something, and space traffic coordination is not something that factors in. And this means that there are all these objects up there, and some of those objects, they rely on external networks like the American SSN to produce an orbit. So they actually use TLEs from SpaceTrack, for example, to locate their own assets. Those assets are usually nanosats and stuff that has been coming on with new space, but still, this is very telling, and this is something that we need to improve. And if we want AI to be able to have access to that ground truth and have access to all the data, you need those data pools, and not only just raw data. You need verified, data, and to get this, everyone needs to do their part in knowing where their own spacecraft is. And once we get access to that ground truth, once the best truth isn't only the truth that is produced by the space surveillance networks from France or from Europe or from the US or anywhere else in the world, we need the laws and the regulations to at least point the operators in the right direction in terms of knowing where their assets are and ensuring that space remains sustainable, and that we can use modern technology like AI to go that way and make things easier.
And then you will probably have the challenge to ask all these operators to share their data, a little bit like what said last morning on the civilian aircraft. Okay. Let's switch to another kind of use case, which is, let's say, addressing, let's say, non-cooperative behaviors in orbit, and to see how you can try to answer that, and eventually with AI. There is an intense activity in research to try to better anticipate intentions of non-cooperative objects. These are not junk objects, meaning passive ones who are dead, but objects with a junk behavior that could be dangerous. It is obviously more complex than just a trajectography of, let's say, known object and operational things that are, let's say, which behavior is known. It's to try to detect, let's say, a behavior which is not expected. It can be, of course, completely normal because there is a problem on board and there is a lack of orbit control, whatever. But it can be as well some dedicated, decisive, decided behavior. In using your current sensing techniques, using your current sensors, and AI, how quick can we be to detect this kind of, change in the situation? let's say, according to my view, it's Michel to start.
So it's me. So I think there are two things. One is predicting, the other one is detecting abnormal situations or behaviors or maneuvers. So this is different. But anyway, this is, for us, this is probably the point where we believe at this stage of our thinking that AI can play a significant role in helping to detect maneuvers as anomalies in a prediction model. So we tried different things at Lookup, and we changed different times the models we used because, like I said in my intro, this is the domain where supposedly we have a lot of data, but we don't have enough data to train models, which is a very important difficulty. So we had to find the right model, and after these different iterations, we have made a very simple model adapted to the problem and to the data that we have. We carried out the training on batches of real data, but also simulated data, because the real data are indeed challenging because they are noisy, they are biased due to multiple sensors and pre-processing most of the time. And we had very interesting results in doing this. Like we built a prediction model that consists in modeling the dynamics of the objects, whatever their orbital regime. And then we were able to detect anomalies in the model through AI. So we think that definitely this is where we can apply AI in the SSA field.
It seems to be quite significant in the way AI can be applied in order to finally to cope with models which are a little bit, let's say, classical, and having faint behaviors detected in the anomalies is useful. Romain, is the same with your network and your techniques?
Yeah, well, pretty much the same. Yeah, the same idea. The same ideas apply. We work extensively. It's been said earlier on time series of orbital data, all kinds of orbital data to detect patterns, etc. Maybe I just want to emphasize how important this subject is, because we've got more and more subjects in our space, and there's this clear strategy from the largest military powers around this planet to use the space junk to hide military capacities in space. And I think, and this has been pointed out by the US, and of course they don't say themselves that they have this capability, but it's kind of implicit that this is the game now. So yeah, detecting space junk, waking up, and revealing some capacities that was unknown is very important, and doing that timely is of course paramount. And for that you need a very good, very well integrated network of networks. I was going to say, so many sensors all around the world, so the work that Michel is doing, what we're doing at Aldoria, is of course key to ensure this level of responsiveness that we need to detect these threats.
How many sensors do you have on Aldoria?
We have 16 sensors on 5 different locations.
And you? Not yet?
So the first radar is being integrated right now in 2 different locations. It will be situated in Lozère, the Lozère department, and we will start the trials of the first version of the radar beginning of 2025. So the first radar will deliver data in mid-2025, and we intend to have 6 different locations using the French overseas territories, which is a strategic advantage that no other country has in the world.
Tahiti is the next after Lozère. Valentin, in your gendarmerie...
Gendarmerie Nationale reporting in. So this is very interesting what my colleagues from Aldoria and Lookup just said, because this is basically the same technology I was talking about earlier when I was talking about regulation and how to enforce it. But this shows that the stakes are very high on this kind of technology, because the applications are very diverse in terms of military, of civilian use. This all comes down to making the catalog, and this is already when I said the catalog is having all the trajectories of all the objects in space. It's already a pretty complex and difficult problem to solve. And we're counting on on companies like Aldoria and LookUp. We are counting on them to start solving that problem first. And once we get that problem solved, the next step is what we were talking about, is pattern recognition, patterns of life. And this is, and so it's a step higher in terms of difficulty, because okay, let's say you have a perfect network of sensors, and you have a perfect orbit determination service that is able to, to produce a whole catalog that is refreshed every hour. That will produce a gigantic amount of data, and you need to sort this out. You cannot just say, okay, I have all this data. What do I do with it? And this is where AI, I think, it's definitely, it will have to be the way to move forward with this.
AI giving purpose. It's interesting. So we've got a couple of questions on the website. So before that, let's try to tackle a very pragmatic case. I am an operator. I've got a satellite, and Aldoria is telling me there is another satellite behind me, 1 kilometer away, following me. Well, suddenly this spacecraft, the follower, takes some maneuvers. He's accelerating, and for the one who knows Kepler laws, if he's accelerating, in fact, he will raise his altitude a little bit, and well, he will. Basically, in the short term, it will be far from us. The 1 kilometer will be larger, and it will disappear. But in fact, thanks to the Kepler law, the next time, and depending on what he will do, the other will do next, it could come with the follower is not anymore 1 kilometer away, but 200 meters away. But you don't see it coming because the thing is happening on the other side of the orbit. So it could be a classical nominal control of the orbit of this one. But it could as well be what I call for my aeronautics, let's say, the military ones, the Cobra maneuver of the Sukhoi, say suddenly he's in front of you and the next minute he's behind you. So it's the Cobra maneuver in the way. So Michel, this parabola is a little bit fancy, but sorry for that. Say, with the three aspects you have in hands, how can you advise the operators to do something or not to do something? To send them some advice of doing things, to have an AI operator on board receiving your data and analyzing everything and say, hey, you should maybe do something or don't touch anything, it will be okay. Is there, it's a complex thing, I know, but why not? Let's try to invite. I am an operator. I'm one of your customers, so you have to satisfy me.
Yeah, we don't run military operations, so like we would leave the responsibility to make the decision to the military operators. That's the first disclaimer. Second disclaimer is that satellites don't like to stay 1 kilometer apart from each other. That's a little bit too close, unless they're very well coordinated. So yeah, we just if the matter is just like providing data all the way through in just half an orbit, which is kind of the situation you depicted, you need a sensor network that's dense enough to ensure this level of responsiveness. And I think yeah, like being able to have revisit rates under the hour and delivery times within a few minutes is typically the orders of magnitudes that our customers are looking at.
It is difficult. You confirm, Michel?
I'm going to say the contrary. Not than Romain, but I don't think it's a very complex situation that you described, actually, because the two spacecraft you mentioned are on the same orbital plane, so you don't need AI to see how much time it needs to get closer to the other one. So actually, with a simple algorithm, you can do that. You can predict the potential RPO situations that are supposed to occur in the next 72 hours, for example. And we already do it at LookUp. We have these algorithms to predict these kind of situations. It's much more complex to address the problem of AI for collision risk prediction and avoidance than to the use case you mentioned.
Okay. The 1 kilometer, there is a range. It's the one who is 1 kilometer away can do things, but cannot. Valentin, my case is really a silly one.
Yeah, I wouldn't say it's silly. It's still not. It falls in the plane of what we call like orbital warfare, pretty much, because there is intent behind, right? And where I would see AI being maybe useful is you can have several strategies to get into that rendezvous proximity operation range, the AI could sort of simulate the intent. Be like, okay, if I wanted to get close to that asset, what are my options? Simulate all the different scenarios and see which one is the likeliest in terms of how things are actually running in real life with the sensor data we're getting. This could be maybe a use case, but like Mr. Friedling said, there aren't that many different scenarios, I think, in terms of rendezvous operations. But where it gets more complex is when you start considering your own maneuvers and how the other will react. And this is where the parameter space gets much better, much bigger. Is okay. I've seen this guy. He's obviously coming towards me, so I'm going to maneuver, and I'm going to keep maneuvering like every 3 or 4 hours, in terms of not being predictable. But when the other sees that, what is he going to do? At each point in time, what is he going to see, and how is he going to react? And this is something where maybe, you get into more simulations and stuff like that, and where AI could play the bad guys and simulate that.
Okay, maybe we'll see with air traffic management if there are similarities. Eric, is there some question that... I know there are questions.
So there are 4 questions. First one for the full panel. In your views, how SSA function should ideally be shared between ground-based and space-based platform, and what is the impact on this on AI development? Should space-based SSA drive onboard embedded AI?
I'm going to give a crack at that, although that's a pretty dense question. Okay, there's a the problem with the space-based space surveillance, so SBSS, is that it's orders of magnitude more expensive to achieve than from the ground, right? It's if you want to observe, if your goal is to observe the whole population of resident space objects, then it's much more cost efficient to do it from the ground. But that being said, the space-based assets they bring more to the table in terms of detectability, in terms of being able to make actual resolute images of objects, which bring more to the table. In terms of business, business plan, it's pretty tough, I think, to have a dedicated spacecraft that only does that. However, it's a good use case for an opportunistic kind of payload that could be loaded on large constellations, for example, and this would definitely bring a lot of information that would complement the ground segments. But I think the bulk of the information should come from the ground, and that's the cost-efficient way to do it.
Yeah, very quickly, I agree with what was said. I think it's very complex, and it's not really cost-efficient to pretend to have a full space situational awareness from space, but it's a very good complement to do other things that you cannot do from ground. So again, I fully agree.
Well, yeah, I pretty much agree. Just wanted to give a couple of examples from the government space and from the new space, because they are quite revealing. I think so one of the biggest changes that we've seen in the U.S. space situation, the U.S. space surveillance network, is that now a significant share of the data produced comes from space-based capabilities. So whether it's dedicated payloads or just opportunistic, like you said, Valentin. So this has been a paradigm shift, and it's really a trend to have a bigger share of the space surveillance data coming from space. It's definitely pulled by specific military use cases. The other trend that we see is that there are some new space players that have been trying to do that for quite a few years, and none of them has been really successful. The only one that has been to some extent successful is a company called HEO Robotics, which acts kind of as a broker between optical capacity that's already on orbit and SSA end customers, basically. So the leverage capacity that's already on orbit. But in terms of launching a dedicated satellite, we've seen North Star struggle over years. We've seen Vioma in Germany making progress, but really slowly, step by step, and the capacity is not deployed yet. So definitely a trend. We have to find the right way, the right business model, and kind of bridging the gap between supply and demand in this area.
And just maybe one comment, the situation is different when we talk about the LEO, low Earth orbits, or the GEO orbits, where we have sensors in GEO which are very efficient to characterize objects and behaviors on the GEO orbit. In LEO, it's much more complex, but again, it's very useful to provide identification of the objects much more than precise and accurate measurement regarding detection, tracking, and positioning.
Okay. Eric, maybe select one only, short and striking.
Okay. This one may be striking. Do you have any evidence that SpaceX is using AI, machine learning, to manage the thousands of collision avoidance maneuvers they perform every year, or is it just an automated algorithm?
So I don't know, I'm taking the microphone, but obviously we don't know exactly what Starlink is doing. So I understand that they pretend that they use AI models to help them manage the constellation. We don't know exactly what they are doing. They for sure use data from other providers, from private companies. But the thing is that they manage 7,000 satellites constellation, which means that they own the data. They know the positioning, constantly the positioning of their satellites. And so they can manage probably this because they own the data, all the ephemeris of their own satellites. And they can compute in between the constellation what is to be done to avoid collisions. But it's a real different problem when it comes to collisions with other spacecraft not belonging to the constellation.
Okay, I think we should close the mini panel. Thank you very much. I think we can applaud them. They have been submitted to hard questioning. Thank you for that.